Assalamualaikum warahmatullahi wabarakatuh. My name is SYAZA AFIQAH FADZIL. I'm from J4EE1113 B1. Okay, today I want to present the video assignment that I have been assigned from SYAZA for ELE232. Okay, the question is about the DC parameter and N channel D MOSFET. Okay, first we need to find the drain current IDQ by using the graphical method that have been given. Okay, for DC analysis, we know that for the capacitor, we need to open circuit it. So, this is open circuit, and this one too. Okay, so if this have been open circuit, so we need to, so it can be removed. Okay, next, for these two resistors, we can parallel it by using Thevenin theorem. Okay, using Thevenin, we can find VTH and RTH. Okay, for VTH, 10 ohm, we need to take the value of resistor that is close from the ground. Okay, so 10 ohm divided by 110 multiplied with VSS. So we get 1.667 volt. For RTH, 110 mega parallel with 10 mega. So we get 9.166.667 ohm. Okay. We already open circuit the capacitor, right? So this is the circuit that we get. Okay. So this is the value of VTH. This is RTH. Okay. This is RD and this is the RS. Okay. From the equation, we get that it already state the value of IDSS and VP. Okay, for the first question is we need to find the drain current IDQ, and next the DC gate source voltage, which is VGSQ. Okay, we need to construct the graph to find the value of IDQ and VGSQ. Okay, since we use N channel of D MOSFET, so we need to find the ID. This is the equation that we use to find the ID. So NVGS, IDSS we get from the equation, which is 6 milliampere, and then VP is negative 3 volt. Okay, don't forget to power of 2 here. Okay, got it. Okay. For VGS, we need to take the negative value. Why? Because the graph it is placed at negative side. Okay, so this is the value that I take with 0, negative 1, negative 2 and negative 3. The more value you take, the more accurate your graph will be. Okay, here from this equation we get the VGS from here, right? So by using this equation, we get the value of ID. Okay. So this is the graph that I get from the table previously. This is the value of VGSV, and this is ID in milliampere. Okay. So ID is from the Y axis, and VGS is X axis, which is ID versus VGS. Okay. Okay, this is N channel D MOSFET, right? So the current flow from drain to source. So after we know the current flow, so we can determine the polarity. Okay, so this is positive, negative, positive, negative, positive, and negative. Okay, so the question, we need to find the value of VGS first. Okay, to find the VGS, we can apply the KVL in this loop. Okay, which is from ground to ground. Okay, so the value of how to apply the KVL. So negative 1.667 plus IG multiplied with the RTH, then plus VGS and plus IS multiplied with RS. Okay, we equal to 0. Okay, next. So this is the equation that we get. Okay, we need to remember that IS is equal to ID, IG is equal to 0 ampere. Okay, so this is 0, right? So whatever value that is multiplied with 0, so the value became 0, right? So we can cancel it. So after that, we can rearrange the equation to find the VGS. So we rearrange it and then we get this equation. Okay. Next, we need to make another graph to find the intersection between the graph from previously. Okay. So I choose ID which is 3 milli, 4 milli, 5 milli, and 6 milli. Okay. The value of ID, we put it in here, and then the value of VGS, we got this. Okay. Okay. It a must that you need to take at least three to make sure that your graph is accurate for the VDSQ and IDQ. Okay. So this is the graph that have been plotted. Okay. We can see that this is the intersection, right? So this is the intersection for IDQ, and this is for the VGSQ. So VGSQ is negative 0.8 volts, and for the IDQ is 3.25 milliampere. Okay. Next, question 3, we need to find the drain source voltage, which is VDSQ. Okay, VDSQ, where is it? This is where VDSQ. Okay. Okay. So we can apply KVL in this loop. Okay. Negative 20 volt plus ID 1.8K, and then VDS. Next, plus with 750 multiplied with IS equal to 0. It is the equation for KVL for VDSQ. Okay. This is the equation that we get previously. Okay, so we know that IS is equal to ID. So this we can change it with ID. Okay. Where we get the value of ID? Why is it 3.25 milli, right? So this value we get it from the graph. Okay. So then we get the value of the VDS, which is 11.7125 volts. Okay. Next, the last question, which is the terminal voltage VS and VD. Okay. For VS and VD, we can add on the voltage source for VD, and this is for VS. Okay. Okay. By look at this circuit, we know that we can apply KVL in this loop to find VD, and this loop to find VS. Okay. So to find VD first. Okay. By using KVL, we can use that negative 20 plus ID multiplied with 1.8K plus VD equal to 0. Okay, that is the equation to find the VD. Okay, then VS, negative VS plus IS multiplied with 750 equal to 0. Okay. Okay, this is the equation for VD. Okay, so we know that ID is previously is 3.25 milli, right? So this is the value of VD. Next, VS. VS, okay, this is the equation for VS. Okay, we know that ID equal to IS. So we can convert IS to ID. Okay. Actually, this is IS, where IS stated, but we want to find the VS, so I change it to ID. Okay. So this is the equation for the value of VS. Okay. Okay. To know whether my answer is correct or not, so I can and I need to use this method, which is VD minus VS. Okay. So 14.15 volts minus with 2.4375 volt. So I get 11.7125. This value is the same as the previous question, which is I need to find the drain source voltage VDSQ. So my answer is correct. Okay. That's all from me. Thank you.